exponent equations that have more than one step. So here we're going to be looking at equations. But again, we're looking for an exponent potentially. There's potentially a power or an exponent that we don't know, like the k in this example here. Or potentially it's a problem where we've got something to a power and we're trying to figure out what it is. So, like we did before, we're going to be thinking about through it in words for ourselves, and also reminding ourselves that we can use all the other exponent and power rules that we have for simplifying when you're timesing terms, or dividing terms, etc. So there's a bunch of different examples here. We'll take an approach to how to problem solve each of them, keeping in mind that guess and check and trial and error are going to be really important as well. So, for the first example, I'm looking at the 3 squared times 3 to the power of k is equal to 81. Okay, so a lot of stuff going on here. I'm trying to figure out for myself what is k going to be equal to. So one way I could be thinking of this, there's probably a couple ways to solve all these problems. I might just role model a few of them, and you can pick what works for you. Is I could just think about it for a minute and say, alright, well, 3 to the power of what equals 81? If I'm not sure, do it out. 3 times 3 is 9, times 3 is 27, times 3 is 81. That's 1, 2, 3, 4. Okay. So 3 to the power of 4 is equal to 81. So I need a 4, and right now I can see that I have a 3 squared and a 3 to the power of k. Well, how do I turn a 3 squared? How many more 3's do I need? What does that k need to be to get me a total of 4 of them? Reminding myself that when I'm timesing algebraic expressions here, I add the powers if the bases are the same. So, I might think to myself, if I had 3 squared times 3 squared, I did that again, it should be 81. If I had 3 squared times 3 squared, that would be equal to 81. In a way that I have 9 times 9 is equal to 81. And also keeping in mind that because the bases are there the same, I can go 3 and do 2 plus 2. 3 to the power of 4 is equal to 81. So my final answer here would be k is equal to 2. And another way that can be helpful to do this is, if you're not sure on the guess and check, is to try to figure it out and actually show what you mean by this idea that you know you can add these powers together. So again, I've got two bases that are the same, a 3 and a 3. I'm timesing them so I can add the power, so I can rewrite that as 3. 2 plus k is equal to 81. And again, I know that 3 to the power of 4 is equal to 81. So this is, again, a second way to look at solving the problem. Did it one way down the left-hand side, here's a second way to think about it. I'm timesing them so I can add the powers. I know in my head 3 to the power of 4 is equal to 81. So in a way, I know that this has to equal this, because I need to get 2 plus k to equal 4 if I want 3 to the power of 4. So, my next step then would be to say 2 plus k is equal to 4. And to make that happen, k has to be equal to 2. So my final answer there is that k is equal to 2. So again, two different ways to visualize that same problem. Reminding ourselves that when you're timesing terms, you can add the powers. In the next example, I see that I've got terms on both sides actually. I've got a to the power of 4 on one side and a 9 times a to the power of 2 on the other side. So what you might remember from other algebra that you've done is that sometimes if you've got more than one variable in there, it's easy if you can combine them into one spot. So what I'm going to think about doing is thinking about dividing that a squared from one side of the equation to the other side of the equation. Because a squared divided by a squared will cancel. And then I can simplify this part over here. So a to the power of 4 divided by a squared. Remember, you subtract powers when you're dividing, so that becomes a to the power of 2 is equal to 9. So I have to ask myself now, what times itself twice, or what squared is equal to 9? And I know that 3 times 3 will get me 9, so my answer could be a is equal to 3. And pat yourself on the back if you are already thinking, there is a second solution to this. Why is there a second solution to this problem? What did we say before? That if you have an even power, and you're trying to find out what that base is, there's two possible ways to do this. we could also have a negative 3. Keep in mind, 3 times 3 is equal to 9, and negative 3 times negative 3 is also equal to 9. So 2 solutions for that. So that's one way to think about doing this problem. Try to think about moving the a squared from one side by dividing both sides by a squared. And for those of you guys who might just be a little bit visual here, just as an alternative solution, again, a to the power of 4, 9a squared. Well, I know I'm looking for 4 things. I've got an a to the power of 2 over here. So if I get rid of an a to the power of 2 on both sides, I'm really trying to say, well, hey, I've got an a to the power of 2, an a to the power of 2, a 9, and an a to the power of 2, because a to the power of 4 is the same as 2a to the power of 2's. Those can go away on both sides. So I'm trying to say here, if these are already the same, I need to make a squared equal to 9 somehow, and how I can do that is by saying 3 or negative 3 is my solution for a. So always a few ways to look at these problems. Moving on, a few more to work through here, hopefully without taking up too much more time. So let's get on to it. Third example here, bracket 2 to the power of k in brackets to the power of 3 is equal to 64. Use your exponent rules. If you've got a power outside of a bracket, what do we need to do? We need to put that exponent onto the exponents inside. So this is going to become 2, and we times, that becomes 3k. Now if any of you are thinking, oh, why isn't that 2 to the power of 3 times k, 3, or getting confused why I haven't turned that into an 8 for some reason. Remember, you times the power by the exponent outside. So 2 does not have a power of 1 here, it has a power of k, which is why I'm not turning it to 8. I'm just going to say 2 to the power of 3k, 3 times k, is equal to 64. And again, in my head, I might think, oh, this is ugly. But how many 2's do I need to get to 64? So let's do it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Oops, 32 times 2 is 64. So that's 1, 2, 3, 4, 5, 6 in total that I need. So in my head, I know that 2 to the power of 6 is equal to 64. So somehow, I've got to make this equal to this. So what does k need to be to get a total of 6 on top there? You can rewrite it if you want, knowing that 3k has to equal 6. And then you can say k is equal to 2. Or you can just think, okay, well, if I've got 3 times what gets me 6? 3 times 2, okay, k equals 2. And again, make sure you actually write down your answer for the k equals 2 there. Next example, 75 plus m to the power of 4 equals 700. Alright, a little bit of algebra to do here. I see numbers on both sides, and I want to get them on one side of the equation. So do to one side of the equation what you do to the other, minusing 75 from both sides. I get m to the power of 4 is equal to 625. Alright, this question then is asking me what times itself 4 times, or what to the power of 4 is going to get me 625. I know in my head that's already going to be 5, but if you didn't know, again, try it. Try it out. 2 times itself 4 times, you don't get there. 3 times itself 4 times, you don't get there. 4 times itself 4 times, you don't get there. Go up to 5 and times it by itself 5 times. 5 times 5 is 25, times 5 is 125, times 5 is 625. Okay, that was 1, 2, 3, 4 5s. So I know that m is going to be equal to 5. And again, is there another possible solution here? Yes, there is, because that is an even power. So we can say 5 or negative 5 as our final answer. Looking at our last example here, we've got 3 m to the power of 7 divided by m to the power of 2 is equal to 729. Lots of steps here. If you see more than one term there with algebra, can we simplify them would be my first question. And m to the power of 7 divided by m to the power of 2, it does indeed simplify down to m to the power of 5 is equal to 729. And I've got that 3 in front. I might think, hey, that's 3 times m to the power of 5. If I divide both sides by 3, I'm going to get m to the power of 5 is equal to, dividing that by 3, you're going to get, again, you got to be able to do this out of the calculator, so however your working needs to work, make it happen. M to the power of 5 is equal to 243. So my next question then is, what times itself 5 times gets me to 243? And if you don't know, try it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's not enough, so let's try something else. What about 3? 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. And that was 1, 2, 3, 4, 5, just like we needed. So my answer here is going to be 3 to the power of 5 is equal to 243. And I do need to write the official answer there, being that m we know is going to be 5. And in this case, there is only one solution, because m to the power of 5, that is an odd power. There's only one solution. If we did negative 5, for instance, negative 5 times negative 5 gets you 25 times negative 5. Oops, sorry. Back it up a second. Yes, you should be laughing at me. My answer there is m is equal to 3, not m is equal to 5. Sorry about that. If it was negative, negative 3 times negative 3 is 9, times negative 3 is negative 27, times negative 3 is 81, times negative 3 is negative 243, which is not the same as positive 243. So there's only one solution here because of the odd powers. Keep in mind, your solution could still be negative. If, for instance, I had actually asked the question instead that said this, 3m7 over m2 is equal to negative 729, then your answer in that case would have been a negative 3 because you need a negative answer. So pay attention to that. There is the possibility of a negative answer or a positive when you have an odd power, but there will only be one of them as a solution. And your hint there is that if it's a positive number, you need a positive answer. And if it's a negative number, you'll need a negative answer. So in this case, the answer would be m is equal to negative 3, because it's looking for a negative, unlike this one, where m is equal to 3 because we have the positive.